So now it is my great pleasure to introduce our first keynote, Deborah Ball. And as you all know, Deborah is worldwide famous for her research in mathematics education, with more than 150 papers or publications. And Deborah has really developed the field with regard to the interplay between theory and praxis. We will learn more about that, I'm sure. Moreover, Deborah is appointed or elected to a number of important and prestigious honorable positions in US, such as the American Academy of, no, it's not the American Academy.
That's right.
What is it? There are so many. So, but it's at least one of them is the American Educational Research Association, of which Deborah, if I recall it right, is elected president. And she is also elected as a member of the American Academy of Arts and Sciences and the National Academy, maybe also, of Education. And in addition, Deborah is a fellow of the American Mathematical Society. So, and there are more to it, but that was only some of the more recent and important things. But even more relevant and more admirable in a way, at least in our context of NORMA, is the fact that Deborah has really, through her whole career, facilitated and developed the interplay between theory and praxis. And Deborah, I have seen you teach, but only on videos, and I'm sure that we will see some of it here, and I look forward to that. And I must say, I really admire the way that you can orchestrate a classroom dialogue and eliciting students, pupils, young primary school children, but also teacher students' way of thinking, mathematical thinking, and use that to build a collaborative learning environment in a classroom. That's really something extraordinary. So I think it's fair to say that your career is an instantiation of what we think of as the idea of interplay between theory and praxis. So we are very privileged to have you here and look forward to your keynote. So please, Deborah, the floor is yours.
Thank you, Morten. Good morning to everyone. It's such an honor to be asked to be the keynote speaker at your conference this year. How does the sound, can you hear me? Okay, if you can't at any point, please tell me. Thank you for that very generous introduction. I somehow managed to get laryngitis on the way over from the US, so I hope that I will make it through the presentation without coughing or losing my voice. The title of my talk this morning is, what is the work of mathematics teaching and how can research contribute to it, which I think fits well with what we're going to do together across the next 4 days. I want to start with an assertion, which is not probably a surprise to anyone in this room, but teaching is a powerful practice. And I'm going to try to unwrap that statement across the presentation. But just to give you an advance warning about this, it works both ways. Teaching is powerful in what it can make possible for young people. They can thrive, they can flourish, but it also causes great harm, sometimes without our realizing it. Sometimes in a single moment, a teacher can do great harm to a student. Teaching is a very powerful practice. I want you to take a moment and talk to the person next to you and name a teacher whom you remember had a very important impact on you, and it might have been a negative one, or it might have been a positive one. So talk to the person next to you and tell that person something about a teacher that had who had a really big impact on you. I'm going to give you 1 minute to do it. So throughout my talk this morning, there will be multiple times where I'm going to ask you to talk with somebody nearby about a video or about a math problem. And so each time I'll raise my hand and just ask us to come back together after each time. So on this image, even here, I think you can see over here, this little boy sitting in the hall is a boy who's been sent out of the classroom for his behavior. And in the United States, very commonly, we see great over-disciplining of Black African-American children. So he's an example of that. In this video, right above him, is a video that perhaps you saw, but it went viral a few years ago of a very beginning teacher in New York City screaming at a young girl for making a mistake in a math class. So those are two examples of harmful moments for children, but there are many moments here where I think we can imagine that students are thriving. How many of you could remember the name of the teacher that you just talked about? Raise your hand if you could remember the name. Okay, how many of you remembered something positive, something good that that person did? Okay, how many people remembered something that hurt or was harmful for you? Okay, I kind of prompted you to think about that one too. So we're starting this whole thing by thinking about the power of teaching and acknowledging that it's not always good, but it can be amazing. Another thing that's worth our remembering is that teaching is the largest occupation in the world. It makes sense if you think about it because young people are the largest demographic group, and so the people who work with the youngest demographic group will be the most numerous professionals. But the numbers are pretty amazing. So in Denmark, there are, for example, 41,900 teachers. It's a lot of people. In Turkey, we have 1 million teachers. The United States, we have just short of 4 million teachers. China, 15 million teachers. And other countries you can see displayed here. But overall, there are 72.5 million teachers in the world. So it's a really large occupation, and perhaps that signifies both its importance, but also the difficulty of recruiting people to do the work, and also the problem of trying to impact the quality of teaching because it's so enormous. So I want to keep in mind that we're not talking about a small and very specialized occupation. We're talking about something that many, many people have to learn to do. And it's actually very difficult work, as you know. So that's a problem when you think about its power and its magnitude. So I guess the thing that I'm trying to say here is that we depend on teaching. We depend on teaching to really develop our most precious resource in any country, which is our young people. The young people in each of our countries are the next generation who will do all the things that we haven't gotten done, problems that need to be solved, research that needs to be done, raising the next generation after that. They're just a very important resource, are the young people. So we depend on teachers for that. So trying to focus now on mathematics education, since we're here at NORMA together, I thought it might be worth our getting a little more specific. What is it that we want to happen from mathematics education? So I make a suggestion of a few things. One is, at least in the United States, there's a lot of talk all the time about the need for the economy and the society to build what is sometimes called a skilled technical workforce, which seems to include many kinds of jobs, many kinds of careers, but there's a concern that we aren't preparing enough people for all the kinds of work that are needed in our society. But a different sort of goal is, at least for us, and I'm curious about in all the other countries that are represented here, we also have a problem of trying to disrupt patterns that have pushed some students out of mathematics because of discipline, because of not believing that they can do the work, because of ways in which we interact with them and they start to think they're not good at math. So in the United States, this mostly has been African American children and Latino children, but in other countries it may be immigrant groups. There are groups that are marginalized in every society, so one goal of mathematics education is to stop that, of pushing people out. A third one is more general. I might call it literacy, which is trying to raise a generation of adults who don't say things like, I'm not good at math, or I'm not a math person. People who basically reject mathematics. We want to raise more people who think of mathematics as an important human domain. And even if they don't do mathematics in their work, they see themselves as capable of it. And finally, there's a goal also of expanding what we even mean by mathematics. Often in schools, the representation of mathematics is very narrow, very focused on getting right answers, for example, or being fast, which isn't really what mathematics is. And mathematics has been also developed by many groups of people around the world, many cultures, many histories. We don't typically expose young people to the wide richness of mathematics. So one goal will also be to expand what young people even come to think is mathematics, but also what it means to be good at it. Because right now, many young people learn something very narrow about what it means to be good at mathematics. So these are some possible goals. But throughout all of this, I'll claim that there's one big thing that we care about, and that is we want to advance what I'm going to call young people's mathematical flourishing. I'm going to define what I mean by that. So when I say mathematical flourishing, I mean a few things. The first thing that I mean is what we would all expect: conceptual understanding, procedural capability, mathematical thinking and reasoning. You can probably add other things like representation, symbolization, many things you could think about, argumentation, but that's sort of what we tend to think of as competence. But another part of flourishing is what I'm going to call positive mathematical identity. That is, seeing yourself as capable, seeing mathematics as worth doing, seeing it as possible to do. That's also part of flourishing, and they're not really separate. They're really part of what it means to flourish, both to be able to do mathematics in a broad sense, but also to see oneself as capable. And there's a sort of overarching societal goal of mathematical flourishing, which is expanding what it means to flourish and who gets to be the people who flourish. So that's what I mean by mathematical flourishing, and it will underlie my session with you this morning. I don't think these are particularly new points that I'm making. I think we've probably talked about these in one form or another for decades. However, even though in most countries there have been years and years of what's sometimes called reform, or efforts to improve mathematics education or improve what students are learning, actually not very much has really changed if you go into most classrooms in the world. That doesn't mean there aren't classrooms where amazing things are happening. Yes, there are. But overall, if you visit a classroom in most countries, you will see things that you would have seen decades ago. So what are some of those things? Often you would see teachers showing students how to do procedures, that getting the answer right would be the main goal in many classrooms. Often the problems that are about applications of mathematics seem to students to be rather ridiculous and not related to anything that anyone really does in the real world. Again, I'm not saying that there are not classrooms where the opposite happens. I'm talking about what happens in general. Some students end up thinking they're good at math while others think they're not. Young people, I've already mentioned this, who are members of marginalized groups often end up excluded from proceeding in mathematics. And in many cases, students are judged by perceptions of their mathematical ability as though that were somehow a fixed trait of humans, which it's not. People are good at some things and not good at other things, and they're constantly changing. And yet often we judge students for whether they're good at math or capable, should be in more advanced mathematics, should be in a group of students that get more help. We tend to use more judgment in mathematics than in some other fields. So this is still happening in many, many classrooms. And you might ask yourself why, because there are so many people in so many countries who are doing research in mathematics education, who work on developing new curriculum materials, who do lots of work to improve mathematics education. This is not a new question or problem. So it's a puzzle to think about why that is. One thing I notice is that what I hear over the years that I've been working in this field is lots of polarized discourses, lots of arguments about what the right thing is to do. Should we have what's sometimes called direct instruction, where the teacher is very clear and explains things, Or should we have more inquiry-based instruction where students are engaged in solving problems and puzzling about things? Should we worry about more like problems that are contextualized in our applications, or should we do things that are more pure mathematics? Should we worry about teacher preparation, or should we worry more about how we deal with gifted students? These things are not dichotomous, and yet these things get argued about over and over. And often people don't even mean the same things by some of these words. And you could probably add others, but lots of argument about mathematics education, which if you're in the classroom or in a teacher preparation program, is going on way up here above where you're working. It's not really all that relevant often. And so that's going on. So what seem to be the common strategies that we've used over and over again to try to boost or improve mathematics flourishing? I think there are at least 3 that are common. One is we rebuild the curriculum or the goals for learning, and every country has new statements about that, and they're tied to PISA or they're tied to other exams, and we make lists. The lists don't vary a lot across countries or even across time, but we do that frequently. We build new curriculum materials, new books, new textbooks, new digital materials. Many people are interested in how you can improve the materials that teachers use with students. And of course, there's professional development and teacher education. So we use these 3 things over and over. And of course, they make sense. There's nothing about them that doesn't make sense. But why haven't they been enough? Why, given the amount of effort that has been made in these 3 approaches, why has that not done enough to really change the quality of young people's flourishing? Why don't you talk to someone next to you and see, do you agree that those are the 3 things? And what do you think about why, after decades of efforts in these areas, why have we seen less change than you would hope? So take a minute to talk to somebody nearby. What do you think? Let's come back together. So this brings me to the main argument of this morning's talk. So my answer to this is what I will try to convince you of in the session today. My answer is that we don't have enough understanding of the actual work of teaching mathematics and its relationship to mathematics learning. And I'm going to unpack what I mean by that, because of course there's much research on mathematics teaching, there's research on mathematics learning. So when I say this, what is it that I'm trying to argue? And that's what the talk is about. So first of all, why do I use this phrase, work of teaching, instead of just teaching? And what do I mean by it? I think that's important for me to explain, because I'm being deliberate to use that word, work of teaching mathematics, not just teaching. So one reason I use it is because so much of the work is invisible and is tacit. People who are accomplished teachers, like many of you in this room, do many things that you don't name or have language for or even quite realize that you're doing. And that's a problem for building a knowledge base. And when researchers study teaching, they often don't even see those things, even though they're visible. When I say they're invisible, it's a bit of a paradox because, for example, think about what happens if you teach very young children, as I do. Often one gets down really close to be face-to-face with a student, to be able to communicate and not be leaning over like a large person over a small human. But we haven't really ever studied a lot about how teachers move in the classroom, what levels they occupy, and how they move. That's actually a big part of the work. And many teachers do this instinctively and don't even have language to explain why they're in the back of the room sometimes, crouching at other times, at the board at other times, and yet it matters where you are in the room. That's just one example. So what that means is there's so much that teachers are doing all the time that just we don't actually understand very much, and it's quite incomplete. And this is a problem, I'm arguing, because if our understanding is partial about that work, that's limiting our ability to support people learning to do the work. If what we think the work involves is confined to the things that research has showed or theory has showed, we're often missing some of the most important things that have remained tacit or invisible. It even affects policy because reform efforts also fall short, like the ones I mentioned earlier, because they're not yet accounting for the work of teaching. So an example of that might be, for instance, that repeatedly developing new curriculum materials is a good idea, but there's a kind of belief among some of curriculum developers that somehow curriculum teaches, and materials don't teach. You can watch one material being taught in 5 or 6 classrooms and see 5 or 6 different lessons. Why is that? Because of all the work of teaching that goes on between teachers and students in particular contexts. So when we build curriculum, it's a partial step, but we don't know enough about what the work is of adapting materials for really helpful use with the learners. So what I'm arguing is that to improve students' mathematical flourishing in all our countries, we're going to have to understand more about what I'm calling the work, and that's what we're going to look at together today. So more focus on the work of teaching mathematics. So what kinds of things do I mean here? These are just names of almost like areas of work. They're not even yet the actual work. Things like I mentioned, using and adapting curriculum materials, or communicating with families. Many teacher preparation programs and professional development programs never ever touch on that very sensitive work of talking with a parent, calling a parent on the phone, sending an email to a parent, meeting with a parent. So many things happen in those meetings, but rarely do teacher preparation programs even touch that work. Connecting mathematics to students' own knowledge and context, that's an important idea, but what does that actually require where you are, depending on the context you're in? What does that look like? You can't build that into the curriculum because contexts vary. And there are a variety of other things. And finally, I want to add one thing that I'm going to spend a lot of time on this morning, which is understanding the density of what I'm going to call discretionary spaces in the work. So by density, I'm going to show you that what I'm calling discretionary spaces permeates, fills the moment-to-moment work of teaching, and we don't pay attention to it or understand it well. And I'm going to argue that that's at least one thing where research and practice need to come much more closely together. So this is the claim that I'm going to argue. I built this a little bit like a mathematical proof. So my claim is we need more research that focuses inside the nuances, meaning the sensitive, delicate, contingent, judgment-filled work of teaching. And there's several parts to my argument. One I've kind of already said, which is fostering young people's mathematical flourishing is essential. We're not going to discuss that. That's an essential. Another is that I've already explained that many efforts have happened over a long period of time to try to do this, and yet we've fallen short. A lot has not changed. And what I'm really arguing today is that the failure to understand in more depth the actual work of teaching is a fundamental flaw in our efforts to improve young people's flourishing. So I'm hoping that this talk will make sense no matter what your role is. If you're a classroom teacher or a school leader, if you're a teacher preparation faculty member, if you work in a program, I hope that the talk will speak to some aspect of your work, or a mathematics education researcher, of where we need to work together to understand the work of teaching better. And I'm arguing that if we had that, it's not that it would prescribe teaching better, but it would allow us to be more strategic in how we help those millions of people who somehow have to learn to do this work. If we were talking about a very specialized occupation or profession where we could select the top 1% of the population to become teachers, maybe we could approach this differently. We could find the people who are born to be teachers, who are natural teachers. But I'm here to say there are not 4 million natural teachers in the United States, not even close. So the people who have to do this work have to be regular adults who have to somehow learn to do this work. And when we inadequately understand that work, we're left without enough resources to support its development. And that has consequences for young people. So this is the claim. We need more research that focuses inside the nuances of practice. And right now, I'm not naming who should do that work. I assume it to be collaborative and engaging different kinds of expertise. So there are two theorems that I'm using to build my argument. What I mean by that are two things I think we already know that I'm not going to try to prove today, but I'm going to use them in my argument. So the first is, I think we know that mathematical knowledge for teaching matters for the quality of teaching, but I think we also know that it's insufficient. Even someone who knows mathematics really flexibly and well, who can hear students, who can explain things in multiple ways, that's crucial, but that doesn't get you enough to help young people flourish. So that's one theorem. I think we also know something I mentioned a few minutes ago, which is good instructional materials matter, but materials don't by themselves do the teaching. So I'm just treating those as givens right now, as though we've already agreed and proved that those two things are true. So my proof fails if you disagree with those. Then we also have lemmas. So the lemmas are the ones that I'm going to spend a little time on. So I'm going to argue that the work of teaching defies dichotomization. It's not an either or, you do this or you do that. It's a good idea to explain, or it's a good idea to let students figure things out. It isn't like that. It's much more nuanced. It requires much more care and judgment and contingency. So it defies dichotomizing either or kinds of reasoning. And the second thing is that the work of teaching requires inherently tremendous amounts of discretion. And that discretion is where we're going to focus today, to see both its risks and its possibilities, and to consider together what it would look like to understand those discretionary spaces better, and what that would mean for the work we all do. So those are lemmas. So I need this little diagram to explain where we're going. Let's look first at the inside of the diagram. So you see students with arrows between them, and you see teachers, and you see stuff. So look first at students. What I mean by that is students are influencing one another all the time in classrooms, for better or for worse. They help each other out. Perhaps they tease each other. Perhaps they help work together. But they're influencing one another, and we should never forget that. Teachers are doing all kinds of things with students, but the reason the arrow goes both ways between teachers and students is that teachers are interpreting their students all the time, who understands what I've just said, who needs more help, who didn't have the background for this. But students are also reading the teacher. What did my teacher just mean when my teacher said that to me? Why did the teacher look at me in that way? Why is the teacher explaining things in that way? I don't like this teacher. All kinds of things are happening. The kids are all interpreting and reading the teacher. And the students and the teachers are all interacting around what I'm calling stuff. By stuff, I just mean that, of course, I mean mathematics, which isn't just stuff. I mean, it could be stuff, but I mean that in classrooms, teachers and students interact about many things. They might be interacting about something that happened in the community, something that happened in someone's home, something in the country, some national event. They talk about many things, and they interact about those. And teachers and students have ideas about whatever they're interacting about. They're not blank. So let's say mathematics. When a teacher begins to work on something in mathematics, the teacher has ideas about that mathematics, but so do the students. And finding the meeting ground so that they're not talking past each other matters a lot. So everyone is bringing things about the stuff as they interact. So this looks like chaos, because the arrows are running every which way. And if you've been a teacher, it feels like chaos on some days. It looks like lots of things happen, and it's hard to see whether students are actually going to learn or flourish. However, I think a really crucial point for us to understand is that teachers have a special role in this diagram, which is teachers are uniquely positioned to be able to be skillful and knowledgeable and understanding in ways that make it most likely that those people, the young people, will flourish. It's a probabilistic argument. Teaching doesn't cause learning, even though we talk about it that way sometimes, but that doesn't let us free, because teaching should be the work where we do as much as we possibly can to make it probable that students will flourish. So that's really important to remember. It's not all chaos. Now that's just inside the classroom in that sort of white circle, but notice they're kind of like little spaces all around that, and that's for the next point I want to make. So the first point is teaching and learning are constructed interactively and interpretively in a context. That's the classroom. But classrooms aren't sealed off from the larger environments. So by environments, I mean many different things. I mean a policy that's affecting what teachers are doing. I might mean things that families really want the school to do that isn't happening, and conflict that could be going on. But I also mean things like histories of a country or a society. So in my country, for example, the long history of discrimination and harm to African American families and students is part of the environment. And there are many things that are normal in schools that come from that larger environment. The way we do testing, the way we sort students, still has a lot to do with race. I don't think that's exactly the same issue in each of your countries, but you have your own histories that influence teaching and learning and schooling through things that are considered normal or typical that influence teaching. So that all sounds like bad things, or at least true things that come into the classroom, and that is right. But the arrows here work outward too. If you want a classroom, let's say a math class, to be relevant to the students, you have to bring things in from the environment, things that go on in the community, things students know about. So you want the classroom to be permeable, but you also have to be aware that things come into the classroom without us realizing it, that are part of things we don't want to come into the classroom. I'll give you one example. A student, actually a teacher, was teaching a class, not a math class, but a writing class. And he told the students, these were 10-year-olds, that in this class we're going to be real authors. We're going to write stories about things in our lives that matter to us. We're going to have a chair where you come when you're the author and you'll read your story to the class, and we'll all be listeners and we'll be critics and we'll help you develop your story. And we're going to be authors in this class. We'll have an author's chair and so on. About a few weeks into the year, something pretty bad was happening. What was happening was the children lived in a community where some children lived in very primitive homes that were very poor, trailers and kind of very small houses that didn't even have water. And some students in that same community lived in much more wealthy houses. And what was happening is that the children began to write stories about children in the class that were mean, that made fun of some of the children who were less advantaged. And the teacher was caught off guard because he had said, you can write about things you care about. And they were writing about their community and about other children, but they were being unkind. And he hadn't thought about how things in the environment that are part of the way people treat one another might just come in through their stories. So he had to stop and back way up to talk about what is okay to write about and what is not okay to write about, and how do we treat each other. That might sound silly to you, but it actually is a very good example of how things going on in the outside world often come inside the classroom. So this isn't a good thing or a bad thing, it just is. And so teachers are always managing, using, and sometimes buffering things in the environment. So the second big point is that teaching and learning are happening in broad historical and social and political environments, and that's a reality. So we need this sort of little bit of theory in order to understand the main body of the talk. So what I'm basically insisting on here is that teaching is really a powerful profession, and when it's done with care, even love and judgment, the students can thrive, They can learn mathematics. They can develop really positive mathematical identities. And they can even learn to value other people's thinking and learn how to work together. School is a really good place for that. When you have a math class where students work collaboratively, they're learning more than math. They're learning about how to listen to other people's ideas, how to think when someone thinks differently than you, if you do this well. But if you don't, it can also be a place where harm happens. Teaching, as we're going to see next, involves incredible amounts of discretion. And basically the point I'm making is that how that discretion is used or exercised can cause harm or can support young people to flourish. So that's the core of where we've been. Okay, so now we're at the proof of my claim. So remember, my claim is that we need to have a much more nuanced understanding of the actual work of teaching if what we want is for young people to flourish mathematically. So we're going to study a video case. We'll be watching a couple of different parts of it, and you'll have a chance to discuss it. The very beginning, we're going to be focusing on 3 children in the class. Their names are Antar, Gabriella, and Gabby. But we will, at the beginning, only be seeing Antar, Gabriella, and Gabby, and then later we'll see the others. So, in this particular video that we're going to see, this is the learning goal. So this is an example of a standard in a curriculum. You may have something very similar in your country. This is common in every part of the United States right now, is a standard about learning to identify fractions. So you can see that it's written very precisely mathematically. It says, understand a fraction 1 over b as the quantity formed by one part when the whole is partitioned into b equal parts, and understanding that a fraction a over b is the quantity formed by a parts of 1 over b. That's a learning goal. So how could this be expressed in a way that's understandable by 10-year-old students? So the goal here is it has to be mathematically clear and precise, but you can't talk like that because that doesn't make any sense to a 10-year-old. So I want you to take a minute with a partner and see, can you rewrite this in a form that's still mathematically precise, but could be said to someone who's only 10? So get a partner. I'm going to give you 2 minutes this time. See if you can find a way to express that in an understandable way. Okay, let's come back together. Let's come back together. I'm going to show one that a group of students for whom I was the teacher developed one year together with me. I'm not saying this is the right way to do it or the best way, but just to give one example of something that was still fit with that, but was usable by 10-year-old students. So this is what they came up with. First, so a set of steps almost. Figure out what the whole is. So for example, if you have 5 cookies, perhaps 5 cookies is the whole. Or maybe you want 1 cookie to be the whole. But when you talk about discrete objects, anything could be the whole. If you're on the number line, it's always going to be from 0 to 1. So that's easy. But if it's not the number line, you have to figure out what whole are you talking about. Then you have to make sure that the whole is divided into equal parts, and if not, then make the parts equal. That was their next step, which fits with that. Then count how many equal parts there are and call that number D. So if there are 5 equal parts, D equals 5. Then write 1 over D to show one of the equal parts. So in other words, if there are 5 equal parts, then you write 1/5. If there are 15 equal parts, you write 1 over 15. And that's an important part of the standard because it says, what's the quantity formed by one part when the whole is partitioned into equal parts? This often gets skipped. Students go right to naming the whole fraction, but the single 1 over b is important. So they have that. And then they had, finally, if more than one of those parts is shaded or denoted, count them, that's n, and then you write n over d. So if you have 5 equal parts, one of them is 1/5. If 3 of them are colored in, then you have 3/5. But there were 2 other things that were important. I don't know if you got far enough to worry about this, but D can't be 0. And I could ask you to say how you would explain that to 10-year-olds, but I won't do that right now. But it's an important question because that is part of the knowing of math. It's part of the work of teaching. If you just announce to the class, D can't be 0, by the way, someone's going to say, why not? And it would be a good idea to have something you could say that's understandable. Or you might just say, you'll find that out later, but that's not wonderful. So, and the other question is what to do about N, because in grade 4, N can only be a whole number, a positive whole number. You don't see negative fractions at this grade level, and you don't see like a rational number in the numerator. So what do you say about that? You could say, right now it has to be a whole number. At least that's more honest. So those are 2 mathematical issues that are part of the work of teaching, of realizing where are you mathematically and how do you take something like that and make it understandable. No mathematician has to know how to do that. But someone who does the work of teaching does need to know how to express that. So that's one part of the work of teaching. Another part is figuring out what instructional activity or task students might work on to learn that. So here's one that was in a high quality, what's called a high quality instructional material that I saw. High quality instructional materials are something everyone is talking about in the United States right now. We'll explain that to you over coffee if you want. So this is the problem. Juanita cut her string cheese into equal pieces as shown in the rectangle below. In the blanks below, name the fraction of the string cheese represented by the shaded part. Do you know what string cheese is? It's like a strip of cheese. Doesn't look like string cheese to me, but anyway. And here's an alternative problem. What fraction of each of these rectangles is shaded gray? So they both are about the same learning goal, but they are different tasks. So I want you to take a moment with your neighbor and notice that both align with the instructional goal. They both go with that goal of learning about naming a fraction. What's the same about the 2 tasks and what's different? So take a minute to analyze what's the same and what's different. This is also part of the work of teaching. Okay, let's come back together. So I think you can see that while both of them involve area models, and both of them have shaded parts, and in both cases, the students are expected to write down the name of the fraction that's shaded. In this case, all the parts are already equally partitioned, so a student just really has to see 1 and 3 parts and write 1/3. They might write 1/2 if they're not yet understanding fractions, because there's 2 not shaded and 1 shaded. But they don't have to do anything about equal parts because the parts are already equal. This problem challenges that notion because both gray parts are exactly the same size and area, but in the one on the left, the parts are divided equally, so it's 1/3. And you can see that although it might be thought to be 1/3, it's not. Now, I do need to say that as a teacher, you have to realize that it would be reasonable to call the second one 1/3, because if it wasn't an area model, let's say it was 3 cookies, you don't care about the size of the cookies. You only care because it's an area model. And that's a big step for young learners to know that when we look at areas, the areas have to be equal. So the problems are different in that important way, and that will be useful for watching the video. So the video is centered on this problem. And we're going to watch first just 2 minutes. And the children have already worked on it by themselves. They've talked to a partner. And what we're going to be watching is the whole group discussion of the problem. So they've already talked about the one on the left we'll be seeing them talking about this one. So on the first viewing of this video, you're going to hear the voices and see the talk of 3 of the children. There are, I think, almost 30 children in the class. You're going to especially see 3 of them, Antar, Gabriella, and Gabby. And what I want you to watch, given what we're working on together, what do you see about the work of teaching mathematics in this video clip? What can you notice? What can you name? Who'd like to answer what you think about the second rectangle? We're only going to be able to talk about this briefly. We probably won't finish it. Who'd like to explain what you think? Antar, what do you think? Could you come up to the board and explain? Thank you. I really like the way the people who are coming to the board are doing today. You're explaining really well. Here's a marker. Can you explain your thinking?
I think it's not a fraction because all of the parts are not equally the same shape.
Can you say that one more time to the class?
I think it's not a fraction because all the parts are not equally the same.
Can someone repeat what Antar said? Very nice, Antar. What did he say? Gabriella?
He said that he doesn't think it's a fraction because not all the parts are equal.
Is that what you said? Okay, would someone like to comment on that, agree or disagree with him? Okay, let's see. How about Gabby?
I disagree.
What do you think?
I think the fraction is 1/4.
1/4? Do you want to come up and say why you think it's 1/4? Antar, do you want to stay there? Do you want to sit down? Okay, thank you very much. You did a good job of explaining your thinking. So let's hear what Gabby's thinking.
I think it's 1/4 because, like he said, all the fractions aren't the same, but you can make them the same by dividing a line down the middle.
Can you go ahead and want to show us here? Here's something you can use for that. Wait 1 second. Instead of drawing it, why don't you just use this? That way if someone wants to take it off again, they can. Okay, so now explain what you've done. Talk to the class, okay?
I divided it down the middle because since it's not equal, you have to make it equal.
And so then you decided?
It's 1/4.
Okay, can someone repeat what Gabby said, what she did and what she said? This actually goes very nicely with what you said, Antar, because Antar noticed that the parts weren't equal, and what Gabby is doing has to do with equal. Okay, so your task for the first viewing was, what do you see about the work of teaching mathematics in that clip? So again, talk with the person near you. What can you name about the work of teaching that's more than the teacher's leading a discussion, which we can see that. What kinds of things do you see the teacher doing? What kinds of things do you see the teacher not doing? That's also part of the work. So you have about a minute to exchange some thoughts on that. So here's this diagram again, and I'm focusing in particular on the interaction between the teacher and students. So that's why the red circle is there. This right here, you don't need to read it, is a transcript of what you just watched. So every line is either the teacher or a student saying something or doing something. And I divided it up like that because I want to make a particular point with you. There are 25 lines in 2 minutes and 21 seconds. And at each of those, the teacher has to do something that the book or the policy or the school head can't possibly tell them to do. They have to make a judgment and do something in that moment. So just to give a couple of examples, the teacher says at the beginning, who'd like to answer what you thought about the second rectangle? We're only going to be able to talk about this briefly. We probably won't finish it. That is a particular way of beginning a discussion. A teacher could say, can someone tell us the answer to the second one? Or any number of other ways to begin a discussion. Nobody tells the teacher how to do that. Even a highly detailed curriculum doesn't say those words and then call on that boy. So the teacher is doing a lot just to get it started. At the point where the teacher is looking around the room to see who wants to make a comment, many students have their hands up. So I know you're familiar with this, but the teacher has to decide who's going to speak. And there are good reasons for any number of students to be the person to speak. But the teacher has to decide and do that. Then when Antar is finished explaining and Gabby wants to go up, the teacher has to decide and do something with Antar. He's still standing there. Should he stay there and be there while she talks? Should he have the option to sit down or stay there? We saw this teacher said, "Do you want to sit down?" But many other things could happen in that moment, like sit down, or you've had your turn, or stay there. This teacher decides to let the child decide. So that's just 3 things out of 25. But each one of those is a moment where the teacher doesn't necessarily decide, but does something. For example, some students were leaning on their heads. The teacher didn't say, "We're going to wait till everyone's sitting up straight." But a teacher might say that. So every one of those lines, the teacher is doing something. So that's what I mean when I said earlier, teaching is dense with discretionary space. And what I mean by that is all of those are moments where it is at our, as teachers, discretion, what we do, what we say, what we don't say, what we do, what we don't do. And this is consequential. So there are a lot of learning goals for this lesson that we're studying right now. Helping students to understand fractions, obviously. Supporting them to work together. That's why you hear the teachers saying things like, "Can you repeat what so-and-so said?" They're supporting mathematical listening, appraising, critiquing, questioning. There's some disruption of what it is to be competent. Antar could be heard as wrong. He said it's not a fraction. But the teacher doesn't pick that up. So the teacher is trying to expand, like, what is it that Antar contributed, and is that important? And supporting the development of positive mathematical identities, and those are just a few of the goals. So we're going to watch the video again and watch a little bit more so you see what happens next. So we'll hear 6 of the children. You'll hear, again, Antar, Gabriella, and Gabby. But then after that, you're going to hear Vershawn, Marquise, and Cassie. And this time, what I'd like you to focus on is, now that you have a little idea of what a discretionary space is, what discretionary spaces do you see in the video? And that could include things the teacher does or says, or things the teacher doesn't do. You're not looking to say if you like the video or don't like the video. It's just, where are the moments of discretion? And I don't necessarily mean decisions. I just mean things the teacher has to do because it's part of the work that aren't dictated by a policy or a curriculum or a book. They're just part of the work. So see if you can name some as you watch this video.
Who'd like to answer what you think about the second rectangle? We're only going to be able to talk about this briefly. We probably won't finish it. Who'd like to explain what you think? Antar, what do you think? Could you come up to the board and explain? Thank you. I really like the way the people who are coming to the board are doing today. You're explaining really well. Here's a marker. Can you explain your thinking?
I think it's not a fraction because all of the parts are not equally the same shape.
Can you say that one more time to the class?
I think it's not a fraction because all the parts are not equally the same.
Can someone repeat what Antar said? Very nice, Antar. What did he say? Gabriella?
He said that he doesn't think it's a fraction because not all the parts are equal.
Is that what you said? Okay, would someone like to comment on that? Agree or disagree with him? Okay, let's see. How about Gabby?
I disagree.
What do you think?
I think the fraction is 1/4.
1/4? Do you want to come up and say why you think it's 1/4? Antar, do you want to stay there? Do you want to sit down? Okay, thank you very much. You did a good job of explaining your thinking. So let's hear what Gabby's thinking.
I think it's 1/4 because like he said, all the fractions aren't the same, but you can make them the same by dividing a line down the middle.
Can you go ahead and want to show us here? Here's something you can use for that. Wait 1 second. Instead of drawing it, why don't you just use this? That way if someone wants to take it off again, they can. Okay, so now explain what you've done. Talk to the class, okay?
I divided it down the middle because since it's not equal, you have to make it equal.
And so then you decided?
It's 1/4.
Okay, can someone repeat what Gabby said, what she did and what she said? This actually goes very nicely with what you said, Antar, because Antar noticed that the parts weren't equal, and what Gabby is doing has to do with equal parts. So these two answers go together very nicely. Can someone repeat what she said? How about Vershawn? What did she say? You didn't know? Do you want her to say it one more time and will you follow it? Okay, say it one more time.
You have to make the fraction the same since it's not equal, and you have to divide it by a part where it's going to be equal.
Now can you explain what she said? Do you want someone else to try? Okay, but follow, okay? Because I want you to be able to follow when other people explain, all right? So who would like to explain what she just said? How about Marquise? Can you do it? What did Gabby say? Can you stand where he can see? He can't probably see so well. What did she do to the second problem?
She added a line to make it. She added a line to make it 2 more.
To make it what?
To make it like this whole piece 2 more pieces.
Uh-huh.
So I could actually.
And why did she do that? Can you say why did you add the line?
Equal.
Can you say that again, Marquise? Why did she add the line?
So I can make 4.
What word did Gabby just say that you need to say? She said she didn't just make 4 parts, she made what kind of parts? Say it again. Equal parts. The same size. You see that, Marquise?
Yeah.
Okay. So, and she came up with 1/4. Cassie?
Well, I just wanted to say I disagree.
You disagree with her? Okay.
I disagree because the question was asking what fraction of the rectangle is shaded gray already before you add the line, and my answer for it was 1 1/2, because you might say it's 1/3, but he's right, it's not equal. So
That was Antar.
Antar said it's not equal. So but there's 1/2 below, like a full rectangle.
Here, we can take the line back off for a minute. Gabby, I think you can sit down. I think you did a nice job of explaining. I can take this line back off. So what are you saying now?
There's the part that is shaded would have to be 1/2 because below there is it's cut up into a half.
This right here?
One above it. So that's how I got my answer 1 1/2.
Okay.
Okay, so take a minute and what discretionary spaces, even if you found one that is a moment where the teacher does or does not do something that has to be at her discretion that you noticed, and share it with the person next to you. You have another minute for this. We could work on this video for several hours and name many, many spaces. So I'm just going to try to take us into a little tour of what it would look like if we actually did that work to understand the density of the amount of discretion that we have as teachers. So here are just a few. What to do after Antar says it's not a fraction because the parts are not equal. There are lots of things that could be done at that point. And we saw the teacher do a particular thing, but there are other things. Where to stand in the room, what to do after Gabriella states her restatement of Antar's, whom to call on, what to do about Antar at the board, what to do when Vershawn can't say what Gabby did, how to respond to Marquise when he holds up his notebook and tries to say what Gabby explained, what to say after Cassie shows why she disagrees with Gabby when the class is pretty much heading toward 1/4, what to do with this comment. So what might it look like if researchers and teachers work together to understand these discretionary spaces? Let's try to examine what that might look like. And again, this will just be a little bit of it. So I picked a few to put on this slide, but I'm going to focus first on what to do after Antar explains it's not a fraction because the parts are not equally the same shape. So there's some possible next moves, and this is just 3. I mean, I think together we could probably come up with many other moves. The teacher might say, Antar, it is a fraction. Can you make the parts equal? Probably quite common that a teacher might decide to do that. A teacher could say, who can help Antar out? A teacher could say, who can say what Antar said? Those are only 3 possibilities after Antar says this slightly puzzling thing, it's not a fraction, because the parts are not equally the same shape. There's some language he's using, the way he's talking. The teacher has to think about what he's saying and decide, what am I saying now? So what are the possible consequences of any particular move? So if the teacher says, it is a fraction, can you make the parts equal? It's kind of making clear that his answer is incorrect and trying to clarify the concept for everyone. It is a fraction. The parts need to be equal. If the teacher says, who can help Antar? The purpose might be to get other students to participate. If the teacher says, who can say what Antar said? The teacher might be encouraging students to respond to one another. So each of these moves has different kinds of impact. So I'd like you to pick one of the others, whom to call on after Gabriella. Gabriella is the one who just repeats what Antar says. Or how to respond to Marquise. He's holding up his notebook. Do you remember that part? And saying, the teacher is trying to get him to say the word equal. And what to say after Cassie shows why she disagrees with Gabby. So pick one of those and try to trace the same analysis. What are some possible next moves for whichever one you pick? And what do you think would be the things to consider and what could be the effect? So pick one with your partner and try to go through the 3 parts of the analysis. So each of these is actually quite interesting, and we could definitely spend time, or if we were a group of teachers working in professional development, we could take one of these and open it up very wide and think about what are the possible moves, what would be the impact of different kinds of moves. Marquise, for example, is being urged to say the word equal over and over, but the teacher's not attending to the fact that he's taking notes in his notebook, which is kind of remarkable, and might have said, I really like that you've been taking notes in your notebook, but that's not what happens. The teacher's deciding to pursue the point about equal. So each of these has many possibilities. I'm going to focus on Cassie as we come to the end this morning. So I often ask people, what do you think would commonly happen next after Cassie says her thing? She says, I disagree with Gabby. The question was asking what part is already shaded. I said 1 1/2. And when you think what would commonly happen in many classrooms, how many teachers might use that discretionary moment, what would be the results? So I'm going to show you what people have said to me frequently about what they think is typical, at least in the US. And you might tell me this is not what would happen in your context. That's fine. But the question you're asking is not what would you do, or what do you think this teacher is going to do, just what do you think is very common for a teacher to do when a student brings up an unexpected answer near the end of class. So I'm going to sort of analyze it in 2 ways. What's normal, meaning what's sort of become very common, and what is the result, perhaps. So one possible normal move that people have told me many times is the teacher might say, Cassie, I see what you're saying, but remember that Gabby just showed us that what the whole is and that the gray square is 1/4. The result of that is Cassie's answer is signaled to be incorrect, and she's positioned as not contributing to the work at that moment. The result is the answer is 1/4. That gets clarified. Another common move would be to say, Cassie, it's really important to identify what the whole is first. Who can show Cassie what the whole is here? Again, that move is focusing on getting agreement about what the whole is. But to some extent, she's being named as not knowing what the whole is, and she's kind of put aside. She clearly is thinking about some kind of whole. So that she doesn't think the same whole doesn't mean she doesn't think about the whole, but that's the consequence. A third one, and I don't know if this happens in your classrooms, but it happens in our classrooms a lot. The teacher might say, thumbs up if you agree with Cassie, or thumbs down if you don't. That might be something to do sometimes, but if no one else has 1.5, then Cassie will be looking at many thumbs down, right? So again, her solution is being voted on, which might also communicate that we vote on mathematical questions, which we don't. But it's a very common response. So the concept of a discretionary space isn't to become paralyzed. It's to recognize how much power teaching has in the moments of what we do. So again, it's dense and they're inherent. They're not going away. Those discretionary spaces will always be in every sort of moment-to-moment work of teaching. So here's my definition to sort of help seal this up. It's a space where interpretations or the next move or the comment or the question are necessarily not determined by the they are determined by the teacher, but not by the policy or the curriculum. A second big important point is, where do these reactions come from? They come from the fact that teachers have spent their whole lives in school. Many things that we do as classroom teachers come because our teachers did those things, or we've seen them, they seem normal. So we all learn these from going to school ourselves. And they're also habits. So the fact that a teacher might say, who can help Antar out? The teacher's not consciously thinking, I want to get people to help Antar. It's just a very common habit of a way to talk in a math class. So if it's a habit, it means that having a broader idea of what you could do instead will take some unlearning of habits. So the density of discretionary spaces, sort of come back to the beginning of the talk, is related to students' mathematical flourishing, and I want to give a few examples. So what are some of the discretionary spaces and risks for harm or possibilities for good in the video we watched? So here's Antar, Gabby, and Cassie. I picked those three, and a picture of the whole class. So, how are these three different African-American children, which is important in our context, being positioned in front of their classmates? Are they being positioned as contributing to the mathematics, as lacking understanding, as struggling? How are they being positioned? Is their smartness, their brilliance, and the fact that they're humans thinking, is that clear? What is signaled across these spaces about what being somebody who does math is? Across the different things we saw, what's the message about what doing math is? What kind of mathematical understanding is developing about fractions? How are Antar, Gabby, and Cassie experiencing their teacher, their peers, this lesson? How are they feeling about it? What are other children in the class learning about African American children and who gets to be smart and who is smart? Because it isn't just the three children, it's everybody's learning about everybody in class. So those are some risks and some possibilities. If Antar gets referred to over and over again, Antar was right. Antar has been positioned as somebody who contributes to class, even though his answer was partly right and partly still incomplete. And he's a black boy. And those things matter in our context, and you have your own examples of that. So in this case, what is some of the work of teaching mathematics for students' mathematical flourishing? Look at the diagram again. So one piece is seeing Antar's explanation and Cassie's question as key to the class's work. And some part of that has to do with knowing mathematics for teaching, like knowing that what Cassie is asking is mathematically important for understanding area models. But if you don't know mathematical knowledge very well, you might just hear her as off, as wrong. Seeing what Marquise is doing instead of what the teacher wants to hear would mean sort of believing that when an African-American boy asks something, he's probably asking a smart thing and doing something smart, not assuming he missed the understanding. But all of those are just like beliefs or attitudes, these first two, or knowledge. But you also have to have some different things to do. Because as I mentioned, the things that we all do, that teachers do, are mostly habit. They're not all conscious decisions. So if you want to be conscious of how does Antar get positioned, you have to notice what you might typically say and think of whether that's what you want to say. And is there something else? So for people who are interested in improving mathematical flourishing, there's of course the important work of identifying mathematical learning goals. That's crucial. But the teaching and learning of mathematics to young people has many more parts to it, like understanding math well enough that's oriented toward the young people's thinking, supporting collective work, and a whole list of things that we've been working on together. So from that instructional goal to the work is a big step with many, many discretionary spaces in it. So the argument that I've been making this morning is we need more research that focuses inside the nuances of actual practice. And what I'm saying really is we have to probe inside that actual work to understand what the work takes and what its demands are. And if we do that better, it will contribute more to our work in professional development, in teacher education, ultimately to young people's flourishing. Because when we don't understand enough about the actual work, we're leaving kind of to habit and to chance what teachers do in all these discretionary moments. So I invite you to think with this idea, how might teachers become more able, how might all of us become more able to notice the discretion we have, to be able to think more about what we typically do and what might be alternatives, and to build more muscle to do some things that are more likely to help students flourish. Thank you. Morton, what do you want to do? You want to take a couple of minutes for questions?
Yeah.
Okay, so I think we have a couple of minutes for questions since we started a little bit late. And there's also a session, what time this afternoon?
There's lunch.
Yeah, but then at 3 o'clock, is that when it is?
After the lunch, at 1 o'clock, session the session.
Right, but when is the meet? When can people talk? There's a meet the speaker.
Oh, at 3 o'clock.
At 3 o'clock, I think if somebody wants to talk more about any of this with me, there'll be a session for that. But what questions might you like to ask right now? We have microphones. Or comments or disagreements. Doesn't have to be a question.
Thank you very much. I come from Norwegian University of Science and Technology. My name is Li Ping Ding. Thank you very much for the presentation. I have one question, because we are doing the research in math education field. And how do you thinking about the teaching? Is mathematical teaching is art or is science? How you actually would maybe say something about the teaching, research in teaching in the math education field, particularly from the perspective, we use in theory, where it's a complicated word. What you would comment about this? Thank you.
So I think you're asking me, do I think it's art or science, and what does this mean for research? Is that right? Yeah. So that's a great question. I think I'm trying to find that space that Morton was talking about, of where research and practice have to be much more interconnected, because I don't really think teaching is either art or science. I think it's practice, and practice itself is inherently both knowledge and things that are consequential, but it requires a great deal of judgment, and there's a lot of space where that judgment and that knowledge has to be used. And I'm arguing we have to understand that better, because if we don't, all the people who become those 72.5 million teachers are going to do things in those spaces anyway. And if we understand those spaces better, we can build ways to support people to use judgment with care and to build better habits. So I think that's like a mix of more knowledge, more theory, because I'm theorizing about discretionary spaces, but I also, I experience it as a teacher of learning to notice these spaces and learning to sometimes pause and say, I'm not going to say that right now, or have new habits about what I say. So I've been thinking a lot about what that is as a teacher to use that space, and I think researchers and teachers can work on practice by understanding that and supporting the use of that. I don't know if that answers your question. Any other questions?
Thank you very much for your presentation. And I'm wondering about Cassie, because I think she's right. She obviously identifies half the square as the whole. And I wonder why this wasn't an issue here to say, okay, that's because you identified half the square as a whole, and then we have improper fractions. But that didn't come up at all. Is that common?
Are you asking what does happen in the video?
No, but no. Is it common that they don't say when you ask the audience that Cassie is right in a way, because she identified the whole as half the square?
Right. Right.
And that never, I mean, is that should be the obvious way to continue, but that
so
doesn't.
you're showing how the way you think about math is broad enough that you recognize that the issue is what's the whole, and she's defined a whole that is half of that whole rectangle, and therefore she's right.
Yeah.
But a teacher who doesn't see that will hear Cassie as wrong. And then she'll still have to decide, what do I say to this girl? What do I do? But you're illustrating the point, is that because you can bring that kind of thinking, you can use that space differently.
Yeah.
Okay. Hi, my name is Selha. I'm working at University of Agder, Kristiansand. I really liked the presentation, nice shots of the classroom. You were young, I guess, when you were teaching too. Good to remember those kind of things. So I want to ask about the learning theories that teachers might have, or the practitioners. How does it change the decisions they are making? And also, there are some theories related to fractions, for example, 5 interpretations of theories. And what we usually saw in the videos is counting, not necessarily like fraction scheme, multiplicative reasoning, how it might be, and how those kind of things can affect the decisions the teacher is making at the spot. So I'm wondering about, what do you think, whether connecting it to the learning theories related to fractions and the action of teachings?
That's a very interesting question. All of these are very interesting questions. Thank you. I think what you're illustrating is how if we as a field wanted to study discretionary spaces more, people who think about learning theory would try to understand how those play out in these moments which aren't all deliberate or conscious, and how would we support teachers to use those spaces in ways that fit with what we understand about learning. Because I'm going to keep saying that much of what happens in these spaces is habit. And so if you're a learning theorist, then studying these can help you think, how do we interrupt patterns of thinking about learning in certain ways that can help teachers respond differently to the mathematics, to the learning. I think that's really helpful because I think different people can contribute, different kinds of expertise could help us understand these discretionary spaces, or specifically how to support teachers to see them and use them with more wisdom. Teachers would have a great deal to contribute to this too, because many things that teachers doing, as I said at the beginning, researchers aren't even thinking about. So it's important to think, what do teachers say about what happens in these spaces, and use that to build the theory as well.
So we have to end the session now, but there will be option for further discussions at 3 o'clock later in parallel with other sessions. So I would end the session here by thanking Barbara for a very, sorry, Deborah.
Similar names.
Deborah, it was a very rich and interesting presentation that you gave, and it really makes us think about the complexity of the practice of mathematics teaching, and how important it is to try to theorize and understand what is really happening in this type of activity, this practice of ours. So thank you a lot, and here you have a very symbolic thing. It's a present. It's maybe you can get addicted to it, so you should be take care. But
Chocolate-covered licorice?
yeah,
Wow.
it's a Danish invention.
Sounds delicious. Can I say one thing? Oh, I have a microphone. Thank you, first of all, for your engagement and all the ways you worked with your partner. I really appreciated how you worked on this. But I also wanted to say one thing that Morten made me think about, is that this is a way of getting past simply saying all the time teaching is so complex, because that's also not so helpful. It is complex, but this is one of the sources of its complexity that we could actually understand better and support our use of that complexity. The complexity is a resource, but when we just say it's complex, it all seems like we're leaving everything up in the air. So I just think that's an interesting question about complexity. Anyway.
Yeah, so now we have lunch in the aula, and yeah, you will find it at the